Hi, this is Jim Weirich from EdgeCase, and I'm here to talk to you about source control made easy. Now, this talk was inspired by a conversation I had with a friend of mine, and we were talking about Git and how it has really kind of changed the way we develop software. It has affected the habits that we have, the way we save changes, the way we have the ability to create local branches and just try things out and commit them or not. And it hasn't always been that way. When we first started using Git, we learned a handful of commands that we used, and we treated Git just like it was Subversion, but with just kind of stranger command names. And it was a little confusing because Git uses terminology that we weren't used to. So once we kind of developed an understanding of Git and how it worked, all of a sudden these commands started making sense to us, and we were able to use Git in a much more effective way. The problem is most people look at Git and they learn it by those handful of commands, and they try to treat Git as if it were a regular source control system like Subversion. So we're going to address that problem. We're going to do it by not talking about Git itself. Instead, we're going to take you on a journey. Let's pretend that you work for a programming house that doesn't currently use source control, and your manager has discovered that, hey, source control, I read about that. That seems like a good idea. So he gives you the job of creating a source control system. Now, unfortunately, you don't have any budget to do this, and you're not allowed to use any of the existing open source systems, so you've kind of got to create one from scratch. So your job is to design and build some kind of source control system that your group can use. We're going to call this the custom source control system, or just CSC for short. And we'll start by thinking back to the old days. You see, back in the old days, when we were working on a system, we'd have a working directory of our files. In this case, we have file 1 and file 2. And whenever we wanted to save off this data, we would create a snapshot. Just use a tar command or maybe a zip command or some other type of command that takes all the files in our directory and packages them up in a single file. We'll use tar as an example here. Now, inside this single file is a manifest that lists all the files that are inside this single tar file, and then also has the data for all the individual files. Now, using the manifest, we can track what files are inside that particular tar file. And so for our first cut at the CSC source control system, we're going to create a command called snap that creates a snapshot just like we did in the old days. It'll create a tar file with the manifest and embedded files. And every time we want to create a new snapshot, we just run the command again and it creates a new tar file. And it will keep track of the version numbers for us. So we can have version 1 and version 2 and create another one. There's version 3. And that works very nice and easy. Now, to get back to a previous version, say we're working on version 3 and we want to get back to version 2, we just untar the file. We unarchive the file into our working directory, and that copies all the files in that tar file into our working directory, and we now have exactly what was in the snapshot for version 2. So it's very easy to create snapshots and to check out new snapshots. 2 simple commands, and that's all we need right now. Very easy, very simple. Now, while very simple, there was also a small problem with our approach. It was a little bit wasteful. Let's look at that. Here's our 3 tar files that we've created, snapshot 1, 2, and 3. And we noticed that we created these snapshots. When we created 2, we changed file 1, and when we created 3, we changed file 2. But that means that file 2 has the same contents in snapshot 1 and 2, and likewise file 1 didn't change between files 2 and 3. We got some duplicate data in our archive. Now, that's probably not a big problem with 2 files, but say you had 100 files and only one file changes between each snapshot. That's 99 files of duplicate data, and we would really, really, really like to eliminate that duplication if we can. Now, what we would like to do is something like this, where we just throw out the duplicate data. However, that doesn't work really very well with the tar format, because tar assumes that all the data is in that one file, and you really can't have manifest files referencing copies of files in other tar files. That just isn't going to work. So we're going to take a radical step and do away with the entire tar file format. We're going to put everything in a single archive, and we will let the manifest files track what should be in each snapshot. We can get back to the exact contents of any snapshot by looking at the manifest files and seeing what the list of files are for that snapshot. The manifest entirely defines that. Now, let's suppose that we found a bug in our project. That bug happens back in version 2. Now, we've already made changes to the code base of version 2. We're getting ready for version 3, and we're working on it, and we've made several commits already. But we found a bug in version 2, and we got to go back and change that code, fix it, but yet not include the changes that we've already made in getting ready for version 3. So, to do that, let's go and check out version 2. And our checkout command goes and finds the version 2 tag, finds the snapshot, points head to that, and then moves all the files in the archive associated with snapshot version 2 into our working directory. So our working directory contains exactly what existed at the point in time we created version 2. Now we go and we fix the bug, which involves editing a few files. We get the files changed. We're ready to make a new commit to our archive. But where's it going to go? We don't want to put it on the master branch, because that's stuff that's getting ready for version 3. We want to put it in a separate branch. So we're going to create a new branch. We're going to call it fix. And that just creates a new branch pointer pointing to our current snapshot that we're working on. Head points now to fix. We go and we create a new snapshot. And the snapshot goes by looking at head, finding out where that is, creating the new snapshot, copying all the files into the archive just like we do for any other snapshot. But now we're on branch fix, so the fix pointer moves forward and points to the new snapshot for that branch. So now we have two branches, master and fix. Master is the changes getting ready for version 3. Fix are the changes that we just did to fix version 2. So let's go ahead and tag this. This is now version 2.1. So that tag's not going to change. It's always going to point to that snapshot. New commits in the fix branch, however, will have the fix pointer advance. But we're done with this now. We want to go back and continue working on the code base for version 3, and that's in the master branch. So we're going to go ahead and check out master. That finds the master branch, gets the snapshot associated with that, copies all the files from the snapshot into our working directory, so we're up to date with whatever is in master, and our working directory matches that now. That's simple. Now, there's one thing I'd like to point out about this, and this is something I really, really like about the CSC source control system. And that's that we didn't create a branch until after we edited the files. CSC gets out of your way. It doesn't make you think about source control all the time. It's just that when you're ready to do some source control stuff, it's there ready to accommodate you. So we didn't even have to create a branch until we were ready to check stuff into our archive. That's a really nice feature.